So this video, we're going to kind of explain a little bit of the difference between what a relation is and what a function is. A relation is just something that we can relate to different sets of with some sort of association. So both the pictures that I have on the screen, of course, these are both arrow diagrams, but they're still both relations. We have the set number 1 here is just 1, 2, 3, 4. Set number 2, we have different types of vehicles, and the association is the number of wheels on from set number 1 to set number 2. Very similarly, we have the same two sets, but kind of in reversed order, and the association instead has the number of wheels. So set 1 has the number of wheels, and then it points to that. And there's a really big difference between these two. What I'm going to do here is I'm just going to start to list out some ordered pairs first off of these two sets. So let's go ahead and let's do the ordered pairs. Now later on, these ordered pairs become x and y coordinates, not so much as just like object from set 1 and object of set 2, but the same principle still applies. So if we're going to do our first, let's call this A and let's call this B. So we'll do A first. So the 1 is going to go with the unicycle. I'm just going to go ahead and put uni here just so that we can save a little bit of time. And then we're going to keep on going down the list. 2 is going to go with the bicycle, but it's also going to go with the motorcycle. So I'm going to say 2 for bi and 2 for, I'm just going to say MO. 3 is just going to go with the tricycle. 3 tri. And then 4 is going to go with our car. I think I can probably squeak it in here. I'll put C. Remember, use our braces when we're doing that. For B, we'll do the same thing. I'll list out the ordered pairs here, but this time we'll see that it's going to be in a slightly different kind of orientation. We're going to name the vehicle first and see how many wheels it has. So bi 2, car, which I'm just going to label as C, 4. We got motorcycle. I named it as MO, is 2. We got the tricycle, so tri was 3. And then, of course, we have our unicycle, which I'll name as uni, is 1. So we have 1, 2, 3, 4, 5 ordered pairs, 1, 2, 3, 4, 5 ordered pairs. But there is a difference between these. And I want you to take a look at this right here. We have this and this. Whereas over here, we have motorcycle, and we have bicycle. Okay, so there's a pretty big difference between what we see in A and what we see in B. And that is, there is a repeated domain value here. Now, our first set is acting as our domain in either A or B. Doesn't matter which one we're looking at. It's always the first set is going to be our domain. So in A, we see that one of our domains actually has a repeated value here. It still means it's a relation, but in terms of mathematics, this is not a function because of the repeated domain value. Not a function. And we can look at that through the arrow diagram and just see that 2 arrows are coming out of one separate domain value, so that could be not a function. Or we can kind of see that in the ordered pairs, that we have 2 of the same domain values splitting up between 2 different of the range values. So we can't have that repeated domain. If we take a look at B here, we see that none of these domains have any repeated values. There's not any 2 arrows going out from one domain value. We could have 2 arrows coming into a range value. That's fine, and that's okay. That doesn't mean that it's not a function. All it means is that we have the same range value for 2 different domain values. And as long as all of our domain values have separate arrows coming out of them, and there's no doubling up or anything like that, this one is a function. And notice in our ordered pair, right? All of our domain values, bicycle, car, motorcycle, tricycle, unicycle, all of these things here are separate. They're all separate domains, or separate domain values, I'll say. Sometimes we use the word unique. They're unique domain values as well. But really what I'm trying to say is here is no repeats. This is really big when we come up to graphing things, and I just want to kind of paint the picture now at least, and then kind of get you set up for a little bit in the future. If I have a domain here, which is our x and y, and this will make sense as the unit kind of go on. If we have a repeated domain value, then these things aren't functions. And they do kind of look a little weird, and we do have to do some other mathematics later on, higher end mathematics, when we're not using functions. But let's just kind of take this for an example. This is something that we're going to see later on in the course, just kind of like a straight line. And what this means is that every single x coordinate has an associated y coordinate that goes with it. So if, I don't know, let's just say this was the x coordinate of, let's say it was 2. Well, this x coordinate of 2 would correspond with only one y coordinate. It would be like kind of a one-to-one relationship. If I said, hey, what's the y value when x is 2? Well, you would only give me one answer. There wouldn't be a separate answer for that. It would only be one y value can go with this x value of 2. Later on in math, and I'm talking about in grade 11, and this is regardless if you go into applied or pre-calculus, some of these functions will start to double up on range values. So something like this, it's called a parabola or a quadratic, that's the name of it. But we can see for a certain range value, so like maybe the second set, and let's say we're talking about a range value of 2, we can have repeated range values, but take a look at their respective domain values. They're both separate. One domain goes with one range. We can have repeated range values, that's fine, that doesn't matter, or repeated second set values, that doesn't matter. But we should only have one domain value going to one range value. And that's really a very big picture idea in terms of this unit, and kind of moving forward with mathematics is what's the difference between a function and a relation. And that function means that it is a type of relation, but a very specific relation in terms of no repeated domain values. They're all unique and they all go to one of our range values. We can double up on range values, that's fine, but bicycle to 2 is different from motorcycle to 2. They both have the same range value, but they come from separate domains. So really, really important portion of this one, and I wanted to just take a separate video just kind of describing that.